We are starting Unit 2 today, so make sure to make a pocket for Unit 2 and then put your Unit 2 divider around our next page. One thing I want you to do is on the bottom of this Unit 2 divider, you're going to write what your goal is for this unit. So it's going to be a short unit, it's going to be a little over a week, and then we're going to take a test over it. So on the front, I want you to put my goal for Unit 2 is blank percent on the test. And write what percent you want to make on your test between hopefully 70 and 100%. So this unit is going to be about domain and range and about whether a relation represents a function or not. So last year we did function or not, so you're going to see that again. But this time it's going to say y is a function of x. That's going to be like the extra phrase that's going to be in there. And then also function notation is going to be included. All right, here's our vocabulary. So let's look. The first thing is a relation. A relation is any set of ordered pairs. So ordered pairs are your x and y. And then a function is a relation where x values don't repeat. So do y'all remember learning about that? X values cannot repeat in order for it to be a function. And then the vertical line test is a visual way to determine if a curve is a graph of a function or not. You draw a bunch of vertical lines, and if it only crosses one, then it's a function. If it crosses whatever's being graphed on here more than once, then it's not a function. Okay, so let's get started on the notes for today, relations and functions. A relation is an ordered pair. And an ordered pair is an x, comma, y. And on the graph, we have the x-axis goes horizontally left to right, and then the y-axis is the one that goes vertically up and down. And then a function is a special relation where for each x there is only one y or output. So put under here y. So basically x's do not repeat. So we're getting to graphs and coordinate pairs, x's and y's, and we're going to make lists from them. And then that's going to help us with domain and range that we get to tomorrow. Okay, let's go ahead and look at example 1. We have ordered pairs. Look at these ordered pairs. From the ordered pairs, we can create a table, a graph, a mapping, and function notation. These are 4 different ways that relations are represented. So a table, we're going to list the x values in order from least to greatest, just like a table on our calculator would be. So these are all the x's. So go ahead and put the x on them, and we're going to list them in order from least to greatest on the x side, and then what they match with. So -2 matches with 4. So I'm going to go ahead and put -2, 4 as my first ordered pair in the table. And then the next one would be 0, and then the y that matches with that is 0. Then the next one is 2, -2. I'm going to put the y there. 2, -2. And then 3, -6. When we graph, we always start with x, sorry. I got all confused. So when you graph, it's x, comma, y. X is your left or right. Y is your down to up. Yeah, how far down? Down or up. There we go. So we'll start with -2, 4. So if the first term is x, -2, that means I'm going to go left, -2, and then y is 4, up 4. So you always start at the origin. So we're going to go -2, up 4. Left, -2, up 4. So -2, 4. And then the next one is 0, 0. That's the origin. So put a point at the origin. And then 2, -2, right 2, down 2. Because x is left and right, y is down to up. So since it's -2, it's down 2. And then 3, -6, you're going to go right 3, down to -6. You don't connect them unless it says it's a linear function. Linear function would mean it makes a line. And it really doesn't make a line, does it? Almost. Okay, now we'll go on to mapping. Mapping, we list all the numbers in order from least to greatest, and then we point an arrow to them. So we're going to list all the x's in order from least to greatest. So -2, 0, 2, 3. And then we're going to list the y's in order from least to greatest. So the smallest one's -6. -6, -2, 0, and 4. Then for mapping, we draw a line from the matches, basically, from the x, because these are your x's, these are your y's. So let's draw a line. So -2 to 4. That would be our first line. Then 0, 0. Then 2 to -2. And then 3 to -6. So that's the mapping. The last thing is function notation. So remember the whole f of x equals y? So what's in the parentheses is our x value. What it equals is our y value. So f of what x gives us a y value of 4? 2. Because look, f of -2 gives us 4. So it's the x value that goes inside the parentheses. F of what gives us 0? What's the x value when y is 0? 0. And then f of 2, now it's giving us the x value of 2. What's the output? Whenever you plug in an x of 2, you come out with -2. And then f of 3, so when x is 3, y is -6. Okay. So these are all the different ways to represent a relation. All right, let's go to the next one. All right, we don't have ordered pairs. We don't have a table. We don't have a graph, but we have a mapping. So the mapping is what x value, this is your x value, so go ahead and put x right there, matches with the y value. So let's list all the x's here in order from least to greatest. -1 is the smallest x because the mapping goes in order from least to greatest. Then 0. I'm doing all the x's first. 3 and then 4. And then we need our y's. So what does -1 go with? What y value? -2. What does 0 go with? 0. What does 3 go with? -1. And 4 goes with 0. What value repeated? Huh? 0 repeated, which is a y. It's still a function, though. All right, now write your ordered pairs. I write them directly from the table. So -1, -2. Oh, y'all can't see that. 0, 0. 3, -1. 4, 0. Okay, now graph them. So remember the x value is left or right, the y value is down or up. So -1, -2. 0, 0. 3, -1. And 4, 0. The last thing we'll do is function notation. So f of x gives us a y. So f of, let's give us an x. What x do we want to use? Let's just start at the top, right? Start with this one. So f of -1 gives us -2. Then f of 0 gives us 0. F of 3 gives us -1. F of 4 gives us 0. Go ahead and glue that in on the next page of your journal.